NEC 700.15 prohibits the mixing of emergency wiring with non-emergency wiring unless the non-emergency wiring is also classified as Class 1, Division 2 hazardous location wiring. When emergency lighting wires operating at 12 volts and line voltage lights operating at 120 volts along with travelers from a three-way switch are mixed together, this appears to violate NEC 700.15. There are potential issues when mixing emergency and non-emergency wiring. Firstly, crosstalk. Electromagnetic interference from the line voltage wiring can cause problems with the emergency lighting system, such as false alarms or malfunctions. Secondly, short circuits. Any damage to the line voltage wiring could also damage the emergency lighting wiring, rendering the emergency system inoperable. Thirdly, code violations. Installing the emergency lighting system in this manner would be a code violation and could result in fines or other penalties. To comply with the code, it is recommended to separate the emergency wiring. Replace the mixed cable with separate cables for the emergency lighting wires and the non-emergency wiring. It is also recommended to install a junction box. Create a junction box at the end of the 350-foot emergency lighting wires. Then pull additional wire. Run new low voltage wire from the junction box to the three-way switch to connect the load wire. This will ensure that the emergency lighting system is isolated from the non-emergency wiring and meets code requirements. The primary concern with mixing emergency lighting circuits with standard power circuits lies in the potential for interference and compromised reliability. Emergency lighting systems are designed to operate independently during power outages or other emergencies, providing illumination for safe evacuation or essential operations. When these circuits are intermingled with standard power circuits, several risks arise. Electromagnetic interference, also known as EMI, can disrupt the operation of the emergency lighting system. Standard power circuits often generate electrical noise and transients, which can couple into the emergency lighting circuits. This interference can cause the emergency lights to flicker, dim, or even fail to activate when needed. This is obviously not desired, as the purpose of emergency lighting is to illuminate for a path of egress. Short circuits or ground faults in the standard power circuits can also affect the emergency lighting system. If a fault occurs in a shared conduit or raceway, it can create a path for current to flow into the emergency lighting circuits. This can damage the emergency lighting equipment, trip circuit breakers, or even create a fire hazard. Furthermore, mixing emergency and standard power circuits can violate electrical codes and standards. The NEC, for example, has specific requirements for the separation and isolation of emergency circuits to ensure their reliability and safety. Violating these codes can result in fines, penalties, or even legal liability. To avoid these problems, it is essential to keep emergency lighting circuits separate from standard power circuits. This can be achieved by using dedicated conduits or raceways for the emergency circuits, or by installing physical barriers to prevent electrical contact. It is also important to use appropriate wiring methods and insulation to minimize the risk of interference or faults. In addition to physical separation, it is also important to ensure that the emergency lighting system is properly grounded and protected by surge protection devices. This can help to prevent damage from electrical surges or transients, which can be common in electrical systems. The NEC addresses emergency systems in Article 700. It covers the installation, operation, and maintenance of emergency electrical systems. Emergency systems are essential for providing illumination and power during power outages or other emergencies, ensuring the safety of occupants and the continuity of critical operations. The scope of Article 700 encompasses various aspects of emergency systems, including wiring methods, power sources, transfer switches, and overcurrent protection. It applies to systems intended to supply illumination and power to required facilities when the normal electrical supply fails. These systems are commonly found in buildings such as hospitals, schools, high-rise buildings, and other locations where the safety of occupants is paramount. One of the key requirements of Article 700 is the provision of an alternate power source to supply the emergency system in the event of a normal power failure. This alternate power source can be a generator, battery system, or uninterruptible power supply (UPS). The selection of the appropriate power source depends on the specific requirements of the emergency system, such as the duration of power outage it needs to support and the critical loads it needs to power. Article 700 also specifies the wiring methods that must be used for emergency circuits. Emergency circuits must be physically separated from normal circuits to minimize the risk of faults or interference. This separation can be achieved by using dedicated conduits, raceways, or cable trays for the emergency circuits. The wiring must also be protected from physical damage and fire hazards. Transfer switches are another critical component of emergency systems. These switches automatically transfer the load from the normal power source to the alternate power source when a power outage occurs. Transfer switches must be reliable and capable of handling the full load of the emergency system. Article 700 provides detailed requirements for the installation, testing, and maintenance of transfer switches. Overcurrent protection is also essential for emergency systems. Emergency circuits must be protected by circuit breakers or fuses to prevent overloads or short circuits. The overcurrent protection devices must be sized appropriately for the emergency load and must be coordinated to ensure selective tripping. Article 700 also addresses the testing and maintenance of emergency systems. Emergency systems must be tested periodically to ensure that they are functioning properly. The testing should include a full load test of the alternate power source and a verification of the transfer switch operation. Regular maintenance is also necessary to keep the emergency system in good working condition. In addition to the general requirements for emergency systems, Article 700 also includes specific requirements for different types of emergency systems. For example, there are specific requirements for emergency lighting systems, emergency power systems, and emergency communication systems. These specific requirements are tailored to the unique characteristics of each type of system. Article 700 is an important part of the NEC that helps to ensure the safety and reliability of emergency electrical systems. By following the requirements of Article 700, electrical professionals can help to protect occupants and maintain critical operations during power outages or other emergencies. It is important to consult the latest edition of the NEC for the most up-to-date requirements for emergency systems. Article 700.15 specifically focuses on the wiring of emergency circuits and the need to maintain their independence from other wiring systems. This section aims to prevent the possibility of a failure in the normal wiring system affecting the operation of the emergency system, which is designed to function reliably during power outages or other critical situations. The primary requirement of NEC 700.15 is that emergency wiring must be kept entirely independent of all other wiring, equipment, and raceways. This means that emergency circuits should not share the same conduits, junction boxes, or other enclosures with non-emergency circuits. The purpose of this separation is to minimize the risk of a fault in the normal wiring system causing a failure in the emergency system. One exception to this rule is that emergency wiring is permitted to be installed in the same raceway or enclosure with other emergency wiring. This allows for the consolidation of multiple emergency circuits in a single location, which can simplify the installation and maintenance of the system. However, it is still important to ensure that all emergency wiring is properly identified and labeled to avoid confusion during maintenance or troubleshooting. Another exception to the rule is that emergency wiring is permitted to be installed in the same raceway or enclosure with wiring for legally required standby systems or critical operations power systems, provided that certain conditions are met. These conditions include that the standby or critical operations systems are designed to operate in conjunction with the emergency system, and that the wiring is properly identified and labeled. The NEC also allows for emergency wiring to be installed in the same raceway or enclosure with wiring for fire alarm systems, provided that the fire alarm system is designed to operate in conjunction with the emergency system, and that the wiring is properly identified and labeled. In addition to the general requirements for separation, NEC 700.15 also includes specific requirements for the type of wiring that can be used for emergency circuits. Emergency wiring must be suitable for the voltage, current, and environmental conditions in which it is installed. It must also be listed for use in emergency systems, which means that it has been tested and certified to meet the requirements of the NEC. The NEC also includes requirements for the overcurrent protection of emergency circuits. Emergency circuits must be protected by circuit breakers or fuses that are sized appropriately for the load. The overcurrent protection devices must also be selectively coordinated to ensure that only the faulted circuit trips, while the remaining circuits continue to operate. The requirements of NEC 700.15 are essential for ensuring the reliability and safety of emergency electrical systems. By keeping emergency wiring separate from other wiring systems and by using appropriate wiring methods and overcurrent protection, electrical professionals can help to protect occupants and maintain critical operations during power outages or other emergencies. In situations where low-voltage emergency lighting wires, typically operating at 12 volts or 24 volts, are run in close proximity to line voltage wires, which commonly operate at 120 volts or 277 volts, and are also intertwined with traveler wires from a three-way switch, several potential issues can arise. These issues are primarily related to safety code compliance and the reliable operation of the emergency lighting system. Firstly, there is a risk of electrical interference. Line voltage wires can generate electromagnetic interference, EMI, which can disrupt the operation of the low-voltage emergency lighting system. This interference can cause the emergency lights to flicker, dim, or fail to activate altogether, compromising their intended function during a power outage. Secondly, there is a risk of voltage induction. The close proximity of line voltage wires to low voltage wires can induce a voltage in the low voltage wires. This induced voltage can damage the emergency lighting components or cause them to malfunction. Thirdly, there is a risk of insulation breakdown. The insulation on the line voltage wires can break down over time, especially if the wires are exposed to heat, moisture, or physical stress. If the insulation fails, the line voltage can come into contact with the low voltage wires, creating a shock hazard or causing a fire. Fourthly, there is a risk of code violations. Electrical codes, such as the NEC, typically require that low voltage and line voltage wires be separated to prevent the risks described above. Mixing these wires in the same conduit or enclosure can violate these codes, leading to fines or other penalties. To mitigate these risks, it is essential to keep low voltage and line voltage wires separate. This can be achieved by running the wires in separate conduits or enclosures, or by using a physical barrier to separate them within the same enclosure. It is also important to use appropriate wiring methods and insulation to minimize the risk of interference, voltage induction, and insulation breakdown. In addition to physical separation, it is also important to ensure that the emergency lighting system is properly grounded and protected by surge protection devices. This can help to prevent damage from electrical surges or transients, which can be common in electrical systems. When dealing with traveler wires from a three-way switch, it is important to ensure that these wires are also kept separate from the low-voltage emergency lighting wires. Traveler wires carry the switching signals between the two switches in a three-way circuit, and they can also generate electrical noise that can interfere with the emergency lighting system. To minimize this risk, it is recommended to run the traveler wires in a separate conduit or enclosure from the low-voltage emergency lighting wires. It is also important to use shielded cable for the traveler wires to reduce the amount of electrical noise they generate. In summary, mixing low-voltage emergency lighting wires with line voltage wires and traveler wires can create several potential hazards, including electrical interference, voltage induction, insulation breakdown, and code violations. To mitigate these risks, it is essential to keep the wires separate, use appropriate wiring methods and insulation, and ensure that the emergency lighting system is properly grounded and protected. When working with electrical systems, it is always important to consult with a qualified electrician or electrical engineer to ensure that the work is done safely and in accordance with all applicable codes and standards. The NEC provides specific guidelines for the separation of different voltage systems to ensure safety and prevent interference. When routing low-voltage emergency lighting wires alongside line voltage wires and traveler wires from a three-way switch, several considerations must be taken into account to comply with the NEC and maintain the integrity of the emergency lighting system. Firstly, physical separation. The NEC generally requires physical separation between low-voltage and line-voltage wiring systems. This means that they should not be run in the same conduit, junction box, or cable tray unless specific conditions are met. The purpose of this separation is to prevent the higher voltage from potentially damaging the lower voltage wiring or creating a safety hazard. Secondly, insulation ratings. All wiring must have the appropriate insulation rating for the voltage and environmental conditions in which it is installed. In the case of emergency lighting systems, the wiring must be suitable for emergency use, which may require higher temperature ratings or other special characteristics. Thirdly, conduit and raceway fill. When running multiple conductors in a conduit or raceway, it is important to comply with the NEC fill requirements. These requirements limit the number of conductors that can be installed in a given size of conduit or raceway to prevent overheating and damage to the insulation. Fourthly, identification and labeling. All wiring must be properly identified and labeled to indicate its voltage and purpose. This is especially important in emergency lighting systems where it is critical to be able to quickly identify and isolate circuits in the event of a power outage or other emergency. Fifthly, grounding. Proper grounding is essential for all electrical systems, including emergency lighting systems. The grounding system must be designed to provide a low impedance path for fault currents to return to the source, which helps to protect equipment and personnel from electrical shock. Sixthly, surge protection. Emergency lighting systems are often equipped with surge protection devices to protect against voltage surges caused by lightning or other events. These devices should be properly installed and maintained to ensure their effectiveness. When running traveler wires from a three-way switch alongside low-voltage emergency lighting wires, it is important to consider the potential for interference. Traveler wires carry the switching signals between the two switches in a three-way circuit, and they can generate electrical noise that can interfere with the operation of the emergency lighting system. To minimize this risk, it is recommended to use shielded cable for the traveler wires or to run them in a separate conduit or raceway from the low-voltage emergency lighting wires. It is also important to ensure that the emergency lighting system is properly designed and installed to minimize the risk of false triggering. Emergency lighting systems are typically designed to activate automatically when the normal power supply fails. However, if the system is not properly designed or installed, it may be susceptible to false triggering, which can cause the emergency lights to turn on unnecessarily. To prevent false triggering, it is important to use high-quality components, to follow the manufacturer's instructions carefully, and to test the system thoroughly after installation. In addition to the NEC requirements, there may also be local codes or regulations that apply to emergency lighting systems. It is important to check with the local authorities to ensure that all applicable requirements are met. Emergency lighting systems are an essential part of any building safety plan. By following the NEC requirements and other applicable codes and regulations, it is possible to design and install a reliable and effective emergency lighting system that will help to protect occupants in the event of a power outage or other emergency. It is always recommended to consult with a qualified electrical contractor or engineer to ensure that the emergency lighting system is properly designed and installed. They can help to assess the specific needs of the building and to ensure that the system meets all applicable requirements. They can also provide ongoing maintenance and support to keep the system in good working order.